Hi and Assalamualaikum. I'm AINA AFIQAH binti AZMI. For this video, we would like to present about two topics, which is chi-square hypothesis test and also two sample t-tests from chapter 5, statistical inference. So let's begin with the first topic, which is chi-square hypothesis test. First of all, I would like to explain first what is chi-square. The chi-square independent test is a method for testing if two categorical variables are related in a given population. So, what is the FITRAH's categorical variable? They don't have any ordering number 1, number 2, and number 3. There is no highest or lowest, so we cannot arrange the variable. So what I'm trying to say over here is that we cannot see that the one particular variable is superior compared to the other. Therefore, if you are looking into this particular characteristic statistical computation, is not viable. For example, the average for gender does not make any sense. Gender male, female, we cannot arrange them. We cannot rank them. And if I'm finding a mean key between male and female, I'm not making sense over here. So now I will share with you some example of categorical variable. So example for number 1 is hair color. You might have someone who is having red color, or maybe you might be blue color, or purple color, or green color. Let's say if I want to do some computations, let's say I'm finding a mean of hair color. I add up, I find the average between red, blue, purple, and green, not making any sense. And I can even arrange which is superior. Whether a person with a green hair color is much more better compared to a person with a purple hair color, and which is not making any sense here. So another example is marital status, which are single, married, divorced, and widower. You can arrange them, probably single people. You can actually arrange them which is superior compared to the other. I mean is you cannot actually arrange them which is more superior compared to the other. And another example is education level. An individual might have PhD, some might have master, some have bachelor, or some have high school certificate. So these are a categorical variable. Therefore, if you want to run any statistical test or you want to do any computation for categorical variable, we have to look into chi-square test. Now we will share with you an example of chi-square test. So the question is, analyze whether gender and genre of movie preferred are related. So assume that we did collect data from every customer who came to the cinema. Then we recorded this thing for customer came in. So in what type of gender they are, and also what genre of movie that they had chosen to watch. So assuming that only 3 type of genre of movie at that time being offered. So basically comedy, horror, and action. So we recorded this data for 40 customers. As you can see here, these are our observed data. So let's start with the step number 1, which is we start with hypothesis. Chi-square test is written in such way the null hypothesis. We see the two categorical variables are independent. It means there is no relationship. So let's say I'm looking into the relationship between between now to see whether gender has any impact on genre of movie. So I will say from writing a null hypothesis, then I will say that there is no relationship between gender and genre of movie. And for the alternate hypothesis, we will see that two categorical variables are dependent. So that means there is a relationship between gender and genre of movie. So that's how we write our hypothesis. Okay. So let's continue with the step number 2 with the next presenter, Ms. FITRAH.
Assalamualaikum warahmatullahi wabarakatuh. My name is FITRAH binti IZHAM. I am from class BA2434L. Now, I will show you the second step of chi-square test. So for the second step, we have to determine the level of significance. So here, the level of significance is 5% level of significance, which is we also call sigma. So 5% of sigma. For the third step, we have to analyze the data. Basically, in chi-square, we need to have 3 tables, which is the first one is the observed frequency table, and then the second one is the expected frequency, and then the third one is the chi-square table. The first one, I insert the table of observed frequency, and then you need to insert the pivot table. In the pivot table, the first one, you have to take the range from gender and movie genre till the end of the data, and then you include the gender in the rows section, and then for the movie genre, you include it in the columns and value section. Then you have the data, the table data, and then the data from the pivot table is just the same for the observed table. So what you have to do is just copy and paste it. After you have done with the observed table, you then need to develop the second table, which is the expected frequency. It's just the same. In the expected frequency, you also have to insert the data of action, comedy, horror, grand total, same as female, male, and grand total. To find the value of expected frequency, what you need to do is you multiply the grand total of a row with the grand total of column and divide it with the grand total of observed frequency. So here I will calculate it manually, and you can see from what I show you here. So what you can see here, you have to insert the equal sign first, and then select the grand total of row, which is 20, and then add the multiply sign, which is the star sign, and then select the column grand total, and then insert the divide sign, which is the slash sign, and select the grand total of the observed frequency, and then you just hit the enter button. You will get the value, which is 7. Same goes as the rest of the value. You have to calculate manually. When you're done with the calculation, you can check whether the calculation is correct or not by getting the same value of grand total for each row and column. After we have done with the expected frequency table, you have to develop the same table for the chi-square. So you have the same data for chi-square, which is action, comedy, horror, grand total, female and male, and also grand total. For chi-square calculation, you need to use the power sign because this chi-square formula have the power of 2. So you need to enter the first you need to enter the equal sign, and then type in power, and then open up bracket 1 and open up another bracket, and then select the value of observed frequency minus with expected frequency. After that, divide with the same value from the expected frequency. Just drag the cursor for the rest of the column, as the formula will be applied automatically for the rest of the column. Then you need to find the grand total for female and male, and then grand total for the chi-square.
Hi, Assalamualaikum warahmatullahi wabarakatuh, and good evening. I'm SYAHINDAH binti AZMAN, and I will continue the lecture on the step number 4 and 5, which is on the decision making and the conclusion for the chi-square test. So let us continue. So after we have finished in step 3, which is on data analysis, we can then proceed with the next step, which is decision making. For decision making, there are a few informations that are required to make decision. So first is on the degree of freedom. Next is the significance level. Then the chi-square value, the critical value, as well as the p value or PV. So to find the degree of freedom, here is the formula, which is R minus 1 times by C minus 1. So R here means the number of row, which is 2, female and male, 1, 2, and C, the number of column, which are 3, action, comedy, and horror. So now we just simply key in the formula. Row minus 1, so 2 minus 1 times with column 3 minus 1. So we get the answer. As for the significance level or sigma is, we can take here, which is 5%, which is 0.05. As for the chi-square value, we can take it from the chi-square value table here, which we have calculated in the step 3. So we have here 4.57. While for the critical value, we must calculate it. This is the formula to calculate critical value, which is CHISQ.INV.RT bracket the probability, which is 0.05, comma the degree of freedom, which is 2. Then we'll get the answer for the critical value, which is 5.99. While for the p-value, here is the formula, which is CHISQ.TEST. So simply key in CHISQ.test bracket the actual range, which we can take it from the observed frequency table here, highlight it, comma, then the expected range. Expected range, which is the expected frequency table here. Just highlight it. Close bracket, enter. So the p-value that you get is 0.1. As for critical value approach, we have to compare the chi-square value with the critical value that we have calculated. Here is the decision rule. If chi-square value is bigger than the critical value, we must reject HO, while if the chi-square value is smaller than chi-square value, we fail to reject HO. So here, the CV that we have calculated is 5.99, whilst our chi-square value is 4.57, which is much smaller. So, since chi-square value is smaller than our critical value, we must reject and we must accept HO, which is we fail to reject HO. Next, for the p-value approach. As for the p-value approach, the PV that we have calculated earlier is 0.1. And for the decision rule for p-value approach is, if our p-value is bigger than sigma, we fail to reject HO. And if our p-value is smaller than sigma, we must reject HO. So our p-value here is 0.1 and our sigma is only 0.05. Therefore, our p-value is bigger than sigma. Therefore, we fail. We again fail to reject the HO. So our HO is, there is no relationship between gender and movie genre, whereby these two variable is not related with each other. Therefore, for the step 5, which is conclusion, we can conclude that movie genre preferred is not depends on gender. It's not depends on gender. we can also conclude that there is no sufficient evidence. There's no sufficient evidence to suggest that there is relationship between gender and movie genre. So whether the customer types of gender is male or female, it does not affect or it does not related to the movie genre preferred by them. So that's all from us. Thank you very much.
So, what is a t-test? T-test definition is a statistical test which is widely used to compare the mean of two groups of samples. It is therefore to evaluate whether the means of the two sets of data are statistically significantly different from each other. Types of t-tests: we have one sample t-test, unpaired two sample t-test, and paired t-test. The one sample t-test is used to compare the mean of a population with a theoretical value. Next, the unpaired two sample t-test used to compare the mean of two independent samples. And the last one, the paired t-test, used to compare the means between two related groups of samples. So moving on to two samples t-test or two sample hypothesis test, with the data given of comparison between both gender, male and female, who has better sense of humor, women or men. So 10 men and 10 women were asked to watch cartoons as either funny or funny. Each participant received a score that represents her or his percentage of cartoons found to be funny. Below are fictional data for 9 people. So here it is, the data. The data already classified as the gender and percentage already classified in according to gender of female and male. So moving on to the next step is the first one is step 1 hypothesis. So the population 1 women exposed to humorous cartoons as well as population 2 men exposed to humorous cartoons. So for the HO we're using equal and for the H1 we're using non-equal. So next is step 2, the significance level. The significance level is 95% while sigma is 5%. So the next step is step 3, analysis. So we click on data and click on data and then we click on data analysis and we choose two sample assuming unequal variances. Click OK, and the first variable, we're going to choose group of females, and the second variable is male. Select on the male, and we don't need to click on labels, so we're going to put on the output range, which is I want to put at this one. And then we click OK. So here it is. The t-test to sample assuming unequal variances.
Hi, my name is Azureen binti Ahmad Farris. So I will be explaining the step 3, which is the analysis. So as you can see here, this is the data of two sample assuming unequal variances. So here I have highlighted the 3 important data, which is the t-stat, p-value, two-tail, critical value, two-tail. Okay, the reason why we choose two-tail because this is two sample assuming unequal variances. So moving on to the next step, which is the decision making. So for the critical value approach, we need to compare the t-test and the critical value. So the value of t-test is negative 0.03, and for the critical value is 2.40. So how to decide whether we need to reject or not to reject? If the t-test is the value of t-test is smaller than the critical value, then we fail to reject the HO. Next, the p-value approach. We need to compare the p-value of two-tail with the sigma. So the p-value is 1.0 and the sigma is 0.05. So we fail to reject DHO because the p-value is bigger than the sigma. So as the conclusion, which is the step 5, there is no enough or significant evidence to conclude that they're either men or women are more likely than the opposite gender on average to find cartoons funny. So that's all from me. Thank you.